Section 5.4, Polynomial Functions. If Section 5.3 was the easiest section in the course, this has to be the second easiest. We're going to be talking about using function notation when we are adding or subtracting functions. Now, these are definitions and they work exactly the way you would hope they do. If you see f plus g of x, they want you to find the function f of x and add it to the function g of x. If you see f minus g of x, they want you to find the function f and subtract the function g. Okay? So what you're going to see are problems similar to this, where they will give you some functions, they will define them for the problem, and then basically what you're going to have is A, B, C, D. So the main thing I need you to understand is these are not the definitions forever. These are just for this problem. Okay? So let's look at this. If these are the functions they give us, and they want us to find f plus g of x. Now, by definition, that is f of x plus g of x. So this is f of x plus g of x. This is my f of x. I'm going to put it in parentheses so it's a little bit easier to see what's going on. But as I said in the last section, because we're adding, the parentheses really don't matter. But they do with subtraction, so it's a good idea to start off with this. Plus, now the g of x is 6x plus 2. So basically, we have to do one step to go from here to here. And then after this, this is a problem we worked in the last section. It's simply combining like terms. And since it's addition, and if we're distributing anything, it would be a positive 1. We can drop the parentheses completely. And then combine like terms. I have x's here. So negative 4 plus 6 would be positive 2x. And then add your constants to get 1 plus 2 is 3. So your answer would be 2x plus 3. Okay, so now what if we have f minus g? I'm comparing that to g minus f. The difference with subtraction, you know, if you subtract in a different order, you get different answers almost all the time. I mean, if you're subtracting 0 minus 0, it doesn't matter, but that's really the only exception. Okay, so this one says I want to start off with f of x, and then I'm going to subtract g of x. And this one means I'm going to take g of x and then subtract f of x. Okay, now I wrote my functions down so that, because I don't want to slide the paper up and down. This means I'm going to find my f of x, which is negative 4x plus 1. And then I'm going to subtract 6x plus 2. And because that's a minus, it really does matter. There's the negative 1 there, you're distributing. So I get negative 4x plus 1 minus 6x minus 2. Now we're going to combine like terms. Negative 4x minus 6x would be negative 10x. And then I have 1 minus 2, which will be negative 1. So I have negative 10x minus 1. Okay, so let's do a similar thing right here. But this time we're going to take g of x first, which is 6x plus 2. And I'm going to subtract negative 4x plus 1. This is a negative 1. I'm going to distribute. And I get 6x plus 2 is going to be plus 4x minus 1. And now combine like terms. 6x plus 4x would be 10x. And then 2 minus 1 is 1. Okay, I want to point out one thing. We've changed the order of subtraction here. And what changed? This was a negative, this is a plus. This is a negative, this is a plus. If you change the order of subtraction, you change the sign of everything. If you think about it with numbers, you'll also see that that's true. If I do 5 minus 3, I get 2. But if I do 3 minus 5, I get negative 2. If you change the order of subtraction, all you're doing is changing the sign. Okay? So let's try another one. This time we have three functions given to us. F of x is x squared minus 9, g of x is 2x, and h of x is x minus 3. And we want to find each of the following. Okay? So this is f plus x of h. So I take f of x squared minus 9, plus h of x, which is x minus 3. Now these are additions, so we can drop the parentheses. And we need to combine like terms and get things in the right order. Our largest exponent is squared, so it needs to come first. There's nothing to combine with it, so I've used that one. Now I use x, so plus x. And then I can combine negative 9 minus 3 to get me to negative 12. Okay, now I had a typo here. This should be f plus g of 3, not x. Okay, now this is the first time we have one with a number, and there really are two ways you can do this. The first way is you could pretend it has an x, do all this work, and then plug in 3 at the end. Sometimes that's the easiest way. Most of the time, it's not. So I could find f of x plus g of x, combine them, and then plug in 3, and it would work. Or I can find f of 3 plus g of 3. And remember your notation. This means you take the 3, and you're going to plug it into your f value. Again, I have these written down. My f is x squared minus 9, so this would mean 3 squared minus 9. That's your f of 3, plus g of 3. I'm going to take a 3 and plug it in here. So this is 2 times 3. Okay, now do your arithmetic. 3 squared is 9, so I have 9 minus 9 plus 2 times 3 is 6. Well, 9 minus 9 goes away, right? So this answer is 6. Okay, now just as an aside, if I had found these with x first, I would have had x squared plus 2x minus 9, and then I would plug in the 3, and you see I would have the 3 squared. Here I would have the 2 times 3, and there's the minus 9. It's the same. It's just a matter of which way is easier for you. Okay, so let's find g minus h of 10. Okay, so that means I'm going to find g of 10 minus h of 10. Now this is a subtraction, so I'm going to need to use parentheses and make sure I've got everything taken care of. To find g of 10, I take 10 and I plug it in here. So this is going to be 2 times 10 minus, okay, I'm going to use brackets here because I'm not looking ahead too much, and I need to plug in 10 for h, into h. Well, h is x minus 3, so this is 10 minus 3. Okay, so I can do the 2 times 10 to get a 20, minus 10 minus 3 is 7. So 20 minus 7 is 13. Okay. Now let's look at this last one. I have g plus h of 1/3. Okay, I've got a fraction here. I'm not necessarily liking it too much. I can find g of 1/3, plugging that in here, find h of 1/3, plugging it all in here, and then see what I get. But maybe because it's a fraction and I don't want to plug it in very much, maybe I want to combine them first. That way I don't have to deal with fractions quite as much. So what I'm going to do is I'm going to find g of x plus h of x and simplify it and see if maybe it's going to be easier. And this is a method you could use on all of these. This is, just one example where this might be slightly easier. Okay? So if I take g of x, which is 2x, and I want to add to it h of x, okay, and I can put this in parentheses too if I want to. but it's addition, so parentheses don't matter. We'll end up with 2x plus x, which is 3x, minus 3. Okay? And then now plug in 1/3. And this is really nice because we end up with a 3 that's going to cancel this out. So g plus h of 1/3 is going to equal 3 times 1/3 minus 3. Because I took this, I found out what g of plus h of x is, and then I'm plugging in the 1/3. So 3 times 1/3 is 1. So I have 1 minus 3, and you get -2. And that's your answer.